What is the intermediate value theorem? Let's build some intuition. Here's the graph of a function with a portion covered up. Can we conclude that this function has an x-intercept somewhere in the covered region? The answer is no. The function could have a hole like this, a jump like this, or an asymptote like this, which each result in the function not having an x-intercept. So what condition would guarantee that this function doesn't have a hole, jump, or asymptote? If you said continuity, you're correct. If we are told that this function is continuous, then we can guarantee that it has an x-intercept somewhere in the covered region. And we can make this conclusion for two reasons. First, because the function is continuous, and second, because 0, which is the y-coordinate of an x-intercept, is between the y-coordinates of these endpoints. For example, if we had a function like this, knowing it's continuous isn't enough to conclude that it has an x-intercept in the covered region, because 0 is not between 1 and 3, which are the y-coordinates of the endpoints. So there are two key ideas behind the intermediate value theorem: continuous and between. And one way of thinking about what the IVT tells us is that if we have a function that is continuous over an interval ab, then the function must take on every y value between f of a and f of b over the interval ab. In other words, for any horizontal line we draw between f of a and f of b, the function must intersect it at least once somewhere between a and b. This can be stated more formally as follows. If f is continuous on AB and k is a real number between f of a and f of b, then there exists a real number c in AB such that f of c equals k. In this first part of the statement, we have our conditions of continuous and between. And the second part is what we are able to conclude from the theorem, which is that there must exist an x value between a and b that corresponds to the y value k. Hopefully this video helped you understand the IVT. Check out my YouTube channel for full-length calculus videos.